Hello everyone, and welcome to the second ANSYS tutorial on this channel. In today's tutorial, you'll learn how to import point coordinates into ANSYS SpaceClaim. As an example, we'll use the coordinate points of the NACA 2412 airfoil. Let's get started. Just like in the previous video, if you haven't watched it yet, you can click the card in the top right corner. First, go to airfoil.tools. Then, open the NACA 4-digit generator. Here, you can change the number of points and adjust other parameters if needed. You can either copy and paste the coordinates directly from this page or send them to the airfoil plotter. For this tutorial, I'll set the number of points to 35. Plot it, and click Send to Airfoil Plotter. Keep in mind that the more points you use, the smoother your airfoil curve will be, and the closer it will match the actual airfoil profile. After downloading the CSV file, open it in Excel.
You'll notice that the file is formatted for ANSYS DesignModeler with separate formats for open and closed trailing edges. To convert it for ANSYS SpaceClaim in 2D, simply delete the second column and leave the remaining columns unchanged. If you want to create a 3D file instead, add a third column filled with zeros to represent the Z coordinates. Then remove the first column and add 3D equals true at the top of the file. For this tutorial, we'll use the 2D format, so simply copy the data and paste it into a new Notepad file. Then add the line Polyline equals true above the coordinate data. Your file is now in the correct format for importing a 2D polyline into SpaceClaim. Now, open ANSYS Workbench and launch SpaceClaim from the geometry cell. Before importing the file, make sure your units are set correctly, just as we did in the previous DesignModeler tutorial. Go to File/SpaceClaim Options. Select Units and make sure the length unit is set to millimeters. Next, go to the Assembly tab and click Import File. In the Import dialog, you'll see several file format options. Change the file type to Point Curve, which will allow SpaceClaim to display text files. Finally, select the NACA 2412 text file and open it. As you can see, only half of the airfoil has been imported onto the XY plane. You can select it from the Select New Sketch plane. Hover your mouse over the XY plane to highlight it, then click to select it. To get a normal view of the sketch, click Plan View, or simply press V on your keyboard. Go to the Design tab and click Zoom to Extents, or simply press Z to fit the entire sketch into the view. Next, inspect the trailing edge of the airfoil. To zoom in on a specific area, you can either click Zoom Box from the toolbar or press Alt-Z. Release the Z key while continuing to hold Alt, then drag a box around the area you want to magnify. Zoom in on the trailing edge to make sure the imported points are connected correctly and the geometry looks as expected.
As you can see, the trailing edge is open. If you'd like to create a sharp trailing edge, you can extend these two lines until they intersect. Go to the Sketch tab and select the Line tool. Then continue each line in the same direction, extending them far enough so they meet at a single point. This symbol indicates that this line is a continuation of the previous line. After drawing each line, press Escape to exit the Line tool before creating the next one. Once the two lines intersect, use the Trim Away tool or simply press T to remove the extra segments and create a sharp trailing edge. If you'd rather create a blunt or square trailing edge, you'll need to use a different approach. As you can see, the x-coordinates of the two endpoints are not the same. Since the lower point has the smaller x-coordinate, we'll draw a perpendicular line from that point. Select the line tool and start drawing from the lower endpoint. It can be difficult to draw an exact 90-degree line by hand, so press Tab to activate the angle input, type 90, press Tab again, and then extend the line until it intersects the upper line. Finally, use the Trim Away tool, or press T, to remove the extra segment and create a square trailing edge. For this tutorial, we'll use a square trailing edge. In many practical applications, a square trailing edge is easier to work with because it produces better quality structural meshes and is often more representative of manufactured airfoils, which typically have a small but finite trailing edge thickness. Now, to create a hollow extrusion, simply select the pole tool and drag the airfoil profile to the desired length. You may notice that the extruded body is divided into multiple surface faces. This happens because the airfoil was imported as a polyline. A polyline is made up of many straight line segments, and during the extrusion, SpaceClaim generates a separate surface face for each segment. If you prefer a single continuous surface, don't worry. You can easily merge these faces afterward using the Merge Faces tool in the Repair tab. Alternatively, you can avoid this issue from the start by importing the airfoil as a spline instead of a polyline. To do that, simply set polyline equals true to polyline equals false before importing the profile. At first glance, both polyline and spline are used to define a path, but they work in very different ways. A polyline is made up of straight line segments. Every point is connected by a straight edge, creating sharp corners at each vertex. Think of it as connecting dots with a ruler. When you extrude a polyline, each segment creates its own flat face, so the final geometry has visible edges and a faceted appearance. A spline, on the other hand, creates a smooth, continuous curve. Instead of forcing straight connections, the points act as control points that guide the shape of the curve. The result is a natural flow with no sharp corners. When you extrude a spline, you get a much smoother surface with fewer faces and a cleaner, more organic look. So if you need precise angular shapes, use a polyline. But if you're modeling organic forms, flowing surfaces, or aerodynamic designs, a spline is usually the better choice. Now, if you want to create a solid extrusion, go to the Design tab and drag a selection box around the entire airfoil profile, making sure to include the trailing edge. Then, click Fill, or simply press F on your keyboard. Once the surface is created, rotate the view slightly so you can see it from an angle. Then, use the Pole tool to extrude the surface and create a 3D solid. That's all for today's video. If you found it helpful, don't forget to hit the like button and subscribe to the channel for more ANSYS tutorials. Thanks for watching, and I'll see you in the next one.